Hi again. So in the last video lesson, we wrote down the equations for the convection using the equation class, equation U convection and V convection equations. And in the equations class, we wrote an explicit method to solve for the new vector field that should be returned by um, returned as the final outcome or the new velocity field. So I actually realized that there is really no need to write this loop because we have already defined the uh, overloaded operators. So we could just initialize a new vector field 2D to the size of the old velocity field, and we could say that because we ask for two things in this function, the delta t value and the old velocity. So we could say that the new one will be equal to the old velocity field minus whatever was given in the constructor multiplied by the dt. It's similarly as in our um, presentation. So delta t multiplied by the constructor argument, which takes the convection terms, and then old velocity will subtract this will be subtracted from the old velocity. Okay, so furthermore, I have actually written, because this vector field 2D, we need to define the value at every I and j node, so just initialize the value to 0.0. Okay, so we can only call this solve method through the equation class, and we can say that the new velocity will be called by this equation class dot solve. It takes the time step size and the old velocity, and the new velocity field will be returned. Whatever is returned here will be equal to the new velocity field, and the return, again, I'm just trying to say it again, the return will be equal to the equation field constructor argument, which is this guy here. So u multiplied by the gradient of u in x, v multiplied by gradient of u in y direction, and it will summate itself together because we defined the overloaded operator for plus sign. So it will be one final field, vector field, which will be returned to in this constructor. Okay, so u new will be equal to this, and similarly let's copy the entire thing, and v new will be equal to v convection equation dot solve, and it will take v velocity as the old one, and we are left with the new velocities. So we have some time steps here, and only 4 time steps at the moment. We can increase that later, but for now our target is to write this, because doing this alone is not enough. We need to visualize and see what is happening. So I have already actually written the file writer class, because it's a bit because this function we wrote together, the write 1D field, but here is similar to that, but this time it will write let me zoom in a bit, u velocity and v velocity. It will take a string, an integer, and two vector fields, namely the u and v, and at the same time the function looks something like this. So it takes the name of the file, the iteration, so the time level, and u velocity and v velocity, and I am trying to give the file an extension of dat, so .dat, and I'm saying that the integer time will be equal to this whatever is passed here, time, and we need to convert this from an int into a string. So I create a string that says it is time name and an OF strings O string stream, which is included in the header file, or all these necessary libraries for the file writing. And I change this into a string by saying that the temp will be equal to the time, and we make a string out of that, the temp value. And finally we have the integer time converted into a string, and then I am appending. So basically appending means, for example, let's say that you passed a string in the main file, main saying that this is out file, and first it will do append. When it comes up to this stage, it will change this to out file and append time name. So time name, let's say if the time was, let's say the time was 10, then it will append 10 here, and then in this stage it will append out file 10, append file type, so it will become out file 10.dat. And the way we are opening this file, a string cannot be passed to fopen. It should be a C string which composes of characters. So the C string is initialized to this entire thing's size, so number of characters there plus extra 2, and the string is copied. So this entire string is copied to this char, and finally we use that char to open the file. So to summarize, we pass in a simple name and a time, we convert that integer time into a string, and then we append the iteration level and the file extension, and then we convert this string into a char type and then open the file. Okay, so nothing complicated there. Let's see. Once we get the file open, we say that the number of X elements will be the rows and the number of Y elements will be the columns of this vector field. So there's two vector fields U and V, and then we say write to the file the variables that we want. So we want to write X, Y, U, V, and then give a new line. In the next line we write, because we are writing in something called a text plot format, which we can visualize in ParaView. So ParaView is an open source software for visualization. So you can download ParaView for free. It has binaries built for Windows, for Linux, and whatnot. So and it's quite not too big in size as well, I think, so you should be able to download it easily. Anyways, the next thing we are saying that all these belong to the same zone and it's in point format, and then we are saying in I there's I number of this points and j number of points, and I is equal to nx temp and j is equal to ny temp, which is described here. And after that we write simply from int I equals 0 to the size of the vector field, we write the values, x position, which is already, if you remember, we passed the grid information to the vector fields, so dot x and dot y, and finally the values. And after this we finally write in a single line x position, y position, u velocity, and v velocity, which is described as doubles here, just to make it easier for the visibility and that. Yeah, so Here we are saying that basically some specifications for significant figures, and that there should be a tab in between each of these. And when we actually visualize this file format, we will come to understand more. And then finally close the out file. Right. So let's go to the main, and I have already written this as string name 2D convection file. This class file writer object is called, and then the function is called write UV, and the name is 2D convection. Time is simply an integer time which is equal to the iteration level, and U and V. So this way we can write the final outcome. But is that really we want? No, we want to see the field convecting away or propagating. I don't know what is the right term for to describe the exact correct word. Anyways, we want to see it move, convecting away, and we should be writing multiple files in order to do that. So there's something called modulus. So like, say for example, if let's say we had a total of 200 iterations, yeah, nt max of 200, and if nt max percentage modulus operator, basically we are trying to get, for example, every 20 or every 100 iterations, then write the file. Okay, so let me just get that into this code. Okay, so we call the file writer, and basically if time is every 20th iteration, then write the file. Okay, so let's copy this function into the for loop, which is the main for loop, or solution ends here. So let's do that, and the name is the string is name, which is called 2D convection. Time is time, and U and V. Okay, so let's hope everything works fine and increase the number of iterations to 100. Okay, let's build this project. I think there is an error where it says that right, I probably have forgotten to delete something somewhere. Yeah, string out file, because I was explaining you something and I wrote. Okay, so it's compiled now. Let's navigate into that directory where everything is, and this is where it is at the moment. So let's run it. 100 iterations are done, and some file is written for from 0, 20, 40, 60, 80. Okay, so let's see what it looks like at the moment. Okay, so it's written some amount of files for every 20th iteration, so 5 files, and we can go to ParaView and click open and navigate to this directory, CodeLight Workspace, build debug, and I think it's in bin. And here we have the series of, so we can open the entire thing and say it's TechPlot and apply and see the U velocity. And so one thing we have to be careful here is that the Y is or X is going towards the right hand side and Y is this way. We can change the color map to something more rainbow type, so something like this. So initially we have a velocity of 1 everywhere but 2 in the middle. So let's see what happens. So it's only moved a very little distance, and a couple of things that we actually missed is really a silly kind of thing, because we initialized u and v, but we forgot to say that u new will be equal to u before we start this time loop. And also we need to here we need to make the old velocities equal to, so u will be equal to u new and v will be equal to v new, and then 400 time steps, and every 50th time step we are going to write the solution using u new and v new. Let's so the debugging is complete. Now we can actually build the project. I think the build is done now, and we can navigate to that directory and run this program. And it has written now about, I don't know, maybe 7-8 files. So we go to ParaView again and open this directory, build debug. It's in the bin folder, and open all this together, and hopefully this time it works fine. So initially we have this, and let's see, so we can see it convecting away, right? If we change the color to rainbow color, it should be more clear. So let's delete this and increase the grid now. Let's increase the grid to a size of, let's say, 50 by 50, and change the time step size, so keep the time step size same. Yeah, let's rebuild it. Okay, so the build is done, and we can go and run again. To be honest, my laptop is a bit slow. It should be, because it's only 2500 nodes, so it should be faster than this. And let's go to ParaView, which I have closed. So let's open ParaView. Okay, ParaView, and open ParaView. Let's wait for it to open. ParaView is open now, so let's navigate there and go to the directory and code light, build debug bin, and tech plot reader, apply, close this guy, zoom in, and say we want to see the u velocity and u direction, and change to something else. This time let's go rainbow desaturated, and right, so there we have it more clear now. So you could write as many files as possible if you want to see what is going on in. Let's check if V is okay as well. Again, change the color to something else. Let's go for yellow, gray, blue this time, and similar kind of thing here as well. So now we see the convection. Right, so in the next tutorial we will be discussing the diffusion term. See you then.